Hello everyone. This is a problem of simple harmonic motion in which a mass hangs from the end of a spring. And first of all, what I would say is just pause the video, read it, read the problem, and try to vision it in your head. And as you see in the problem, the mass is hanging at the end of the spring and it rests 1 centimeter, 174 centimeter above the ground. What that means is you can clearly see that in the second diagram that originally it is actually resting at 174 centimeters. What that means is in the periodic motion 174 centimeter is our midline. Now after this they said that you pull the mass downwards until it is 160 centimeter above the ground. You can clearly see in this diagram that it is pulled to 160 centimeter downwards, okay, and it is 160 centimeter above the ground. What that means is 160 centimeter is our minimum value, and since this is in simple harmonic motion, if you consider 174 as your midline, which we call equilibrium position, then the maximum height it will go up will be 188. Why it will go to 188? Because the distance should be same. You can calculate the distance between 160 and 174 is 14 centimeter, and the same is the distance here between 174 and 188 centimeters is 14. So now the next line of the problem is that the mass oscillates up and down and it completes 20 full cycles. What that means is if it completes 20 full cycle, that means the frequency is given to you. So how much is the frequency? It's 20. So if frequency is given to you, and we know that period is reciprocal of frequency, so it's gonna be 1 over 20, but actually it is 20 full cycles per minute. Basically, it is 20 over 60 here because in seconds you have to divide with 60. So the period will be 60 over 20, which is 3. So now you can imagine we have a wave which starts at 174. I'm talking about the graph of this function, and it go all the way up to 188, and then it will go down, and then it will again reach its equilibrium position. At this point, the period since is 3, so the x value here we have is 3. So it is clearly making a periodic function. It's a sine wave. And now, since we have to write the equation ht that models the height and the mass above the ground, so let's try to draw the graph of this function. The first thing you will do is, in this particular graph, is label the x and y axis. So x-axis we have time t along x-axis. Y-axis we have height h, which is a function of time t. Yeah, and we drew the graph. It's a sine wave. And when we have a sine wave, how would you write the equation? So the equation of this sine function will be a sine b times x minus h plus k. Now you clearly know that a is the amplitude, and in this case the value of a is 14 because that is the difference between the different values. So a is 14. Now in order to find b value, since we already know the period, so b value will be 2 pi over the period. So it is going to be 2 pi over 3. And once you know A and B value, of course, since its equilibrium position or the midline is at 174, so that is the value of K. So K in this case is given to you is 174. So plug in all these values in the formulas. Your final answer will be HT equals 14 sine. Now B is 2 pi over 3 and then we have x, but there is a no phase shift, so h is 0, and k, which is the midline, is 174. Now you can clearly see this is the equation of this simple harmonic motion of the spring, and we can use this equation to find its motion at various time. Like, I have used letter x here, but since in this particular question we are using t along x-axis, you can replace it with t. Thank you, everybody.